Now we would like to move to the second topic, which is PC girder bridge design. For considering this PC girder bridge design, firstly, I would like to explain some of the useful function in MIDAS Civil, how we can make the PC composite girder. There must be the various way, like the modeling deck using the plate element or making the grillage model. In MIDAS Civil, good point is for even though we consider the composite action, like the only girder is there and then after the deck will be installed, considering this composite action, we can still use the 1D beam element using this composite section. So 1D beam element have such shape, like the composite of the main girder and the deck. And as you can see, for the section property, before composite action, after composite action can be viewed in the separate column. If you are dealing with any general shape of the composite section, we can also use this SPC, section property calculator. So infield type of the composite section or any general shape of the girder can be considered using this. And then we can bring it to civil and we can even design it. So using this composite section for construction stage function, we can specify different construction stage that main girder will be activated and the deck will be activated with the different age of the concrete. And then that will be considered in the construction stage analysis. MIDAS Civil provides the various way of considering the time-dependent effect. Most accurate way will be performing the time construction stage analysis with the creep and shrinkage elastic modulus effect with this function specified by the code or specified by the engineer. But instead of this way, if you are more familiar with the practical way, which use the 3N for the long-term effect, it is also available in MIDAS Civil, as you can see from here. For the long-term effect, we can specify different elastic modulus factor, and then it will be considered. The other way, most simple way is I don't want to consider any construction stage analysis. In that case, we can simply specify which loading will be applied in the pure girder before composite action by specifying the load which will be applied before composite action and after composite action. By doing so, program can also consider this composite action. So all different way MIDAS will support. Entering the tendon will be one of the most time-consuming work for you. For the easy generation of the tendon, we provide the various way. Surely we provide the defining tendon by coordinate, but instead of that, we can also use the template and also auto-generation function. For some database section, for example, like the UK database precast section, in this case, by specifying their section name, then this trend can be automatically generated. And this is the tendon template. So we can specify the shape of the tendon we want to enter, like the straight tendon, harped, or curved tendon. And then the tendon can be easily entered. This data will be automatically converted with the certain coordinates. So this was the previous way MIDAS Civil used to have. And in the new version, latest version, we have all different type of the method for entering the tendon more easily and quickly. You may want to consider also reinforcement for the composite section, like for the deck. For that, we can also enter the reinforcement, and that can also be considered in the analysis. For calculating the section property, this reinforcement can be considered. When you are dealing with the plate element, the most difficult part could be the calculating the resultant force, because for the plate element, we just get the force by unit length. So converting those force by unit length into the resultant force, just like the beam element, will be also another time-consuming job when you are dealing with the plate element. But using this resultant force diagram function, we can obtain the plate force just like the beam element. Diagram can be obtained, and for each of the position, the force, like such axial, shear force, moment, can be obtained in the table format. And the other new function is the wizard, like the steel composite girder bridge wizard and the PC composite girder bridge wizard. Steel composite girder bridge wizard has been released, and you can use them in the latest version. And PC composite girder bridge wizard is coming within a month. So in the upcoming version, which will be released very soon, you can use the PC composite girder bridge wizard as well. How it works? This is similar to our previous wizard, using the simple input like the bridge layout, section, loading, and even the construction sequence. Then such bridge can be automatically generated. One special thing in this bridge wizard is not only the beam element, but also the plate element can be considered. So which type of the bridge you want to generate, like everything grillage model, or you want to all the element like the main girder and deck using the plate, or you want a combination like main girder as the beam and the deck as the plate. So specify the type of the bridge you want to generate, and they will be automatically generated. Taper section can be considered, and the bracing also automatically considered with the various shape of the bracing, like X bracing, K bracing, and single beam. Construction sequence, also considering the deck pouring sequence, is considered, as you can see. So using this simple input, the girder bridge can be generated. After generating such bridge, now we want to design them as per the Eurocode. For this bridge design, also MIDAS provides you the detailed design results. Which results we can check? For example, we can check the flexure strength, shear strength, and the stress for each construction stages, and also stress at the end of the construction stage, which is the service stage. And also we can verify the tendon stress and crack width. In case of the flexure resistance, so we can calculate the resistance considering the tendon primary force. And then it will be compared with the member force obtained considering the construction sequence. If we want to consider the crack of the concrete for the deck, like in the negative moment region, in that case, that can also be considered in MIDAS Civil. So if we consider the cracked section in the section manager, then we can also simulate the crack in the negative moment region section. We can also verify the stress. So for each different position in the section, we can verify the maximum stress, and it will be verified with the allowable stress. Allowable stress is determined as the 70% FCK, which is the limit value when the tendon pre-stressing is transferred. And also we can calculate the crack width. So exact crack width can be calculated based on the formula in the Eurocode. And it is compared with the limit value of the crack, which is referring to the exposure class that user will specify. Finally, what you will have is this detailed Excel format report. MIDAS Civil will give you all the detailed results after doing the design, so such detailed report can be obtained. So let's see how we can do all this process using MIDAS Civil. So starting from the scratch, let's try to make the PC composite girder bridge, and then let's check the also design results as well. For the purpose, I would like to make the main girders first. Instead of using the wizard, I would like to show you firstly how we can make such a girder bridge from the scratch using just the generation of each of the beam element. So making the main girder and specify their material and section. So one girder has been generated. Using this, I want to also generate the other girders by translate them in the y direction, specify the desired dimension, and then they will be copied 3 times like this. Main girder, longitudinal girder has been generated. Now I want to have the crossbeam for this grid model. How to make the crossbeam is, if we go to the extrude function, we can easily extrude node to element. So from here to here 3 times, and specify desired material and the section property, then they will be extruded. After that, let's say I want to have a different section property for this end beam. In this case, how I can do that? Simply drag and drop, that's all. So I want to assign them to this section property. Drag and drop. Section will be automatically changed. So generation of this such bridge is very simple and easy in MIDAS 7. So geometry has been completed. Now I want to add tendon. I mentioned there are several ways in entering the tendon MIDAS 7, like the specifying the coordinate of the tendon one by one using this function, or we can use the quick generation function. I would like to show you the quick generation function, which is the new method in MIDAS 7. So we can go to the prestressed bridge and tendon template, and then we want to select the desired girder, which is the first main girder, and using the auto generation, we can specify the corresponding main girder type. My girder type is TY8, so once I click OK, you can see the cross section, how the strand will be entered in the plan view, elevation view, and the cross section. And apply. Want to repeat the same procedure for the other girders. So entering the tendon, entering the strand is very simple and easy using this auto generation function. Once I entering all the strand, now if I want to graphically check my strand, we can check it like this. So strand has been entered for the corresponding main girders. Very easy and quick. After that, I want to specify the value of my prestress. So go to the prestress, and then specify the desired strand, and enter the value for the prestress load, and then apply. So it will be entered. How I can know whether it will be entered or not? Using this worktree, we can see tendon prestress load has been entered. Even I can access to the table easily. And all the value can be verified from here. If required, we can even change a certain value from the table. Just like the MS Excel, you can easily copy and paste a certain value. So tendon has been completed. And let's try to define the boundary condition. For the boundary condition, I can go to the supports, and then for this node, I want to restrain all the translation. This node, I want to release the longitudinal direction translation. For these three nodes, I want to restrain y direction movement. And the other three, I want to restrain only z direction. So support has been easily defined, that's all. Now I want to generate the construction stage. Before do that, I need to have the group. Why I need that? When we define the construction stage, we can define construction stage using group, like structural group, boundary group, and load group. So by activating or deactivating such group, all the construction stage can be generated. So for the purpose, I want to specify corresponding groups. Firstly, for the main girder, I want to select my desired main girders, and then I can drag and drop. For the interior beams, and also for the end beams, they has been assigned. Boundary or loadings are already assigned, so I will skip this part. And now we can go to the construction sequence definition. I will make the three different construction stages, starting from CS1. Either have the 30 days duration and only the main girder, and the cross beam will be activated with the age 28 days, and boundary group and the loading will be activated in that stage. And in the second stage, with the same duration, now the deck will be activated. So cross beam should be also there in this stage. And in the third stage, for checking the long-term effect, I just want to specify their duration only. That's all. Construction sequence has been defined, and I mentioned this is the 1D beam element, but we can simulate the composite action using this 1D beam element. How it is possible is using the composite section for construction stage. So in this menu, you can specify the desired girder. It will be composed of the two parts, main girder and deck. And if their material property are different for the main girder and deck, we can specify different stage, different material, and also stage will be different. Main girder will be activated in the first stage, deck will be activated in the second stage. And for the age, we can specify their age for different age for the part 1 and 2, and notional size for the creep and shrinkage calculation. Okay, so now let's check whether our construction sequence has been correctly defined. As you can see, the end cross beam and the main girder are there. In the second stage, now deck has been activated. Third stage for the long-term effect. So as you can see, with the very simple input, we have generated the such PC composite bridge, and construction sequence has been very easily defined. Now I want to specify moving node analysis as per Eurocode. For the purpose, firstly, I need to specify the moving node code as Eurocode. Only 3 steps required for the moving node analysis. Firstly, let's define the lane. Once we define the lane, program will find you most critical vehicle position inside of that lane. The load should be distributed along with the crossbeam, so I should specify the crossbeam group, and by clicking to node, lane will be automatically generated. For the other lane also, I want to have So 2 lane has been generated. For the vehicles, we can use the standard vehicle as per the Eurocode, or we can specify our own value, even as per the Eurocode. So default value is based on the code, but if you need to change any value, you can also do that. Also in the Eurocode, so we need to specify load model 1, or depending on the bridge type, you may want to consider the bridge load model 2 or special vehicle like load model 3 and load model 4 as well. You can select any of the desired load model. In case of load model 1, different vehicle loads should be entered depending on the lane number. Like most critical lane, we should enter the vehicle load. As you can see, the 300 kilonewton. But in the second critical lane, the loading should be 200 kilonewton and so on. So depending on that, program can automatically find which lane is most critical, and then corresponding load will be automatically determined. So it will be also very useful for you. Instead of you determine the critical lane, program will determine for you. Not only the road bridge, if you are working with the footbridge or the fatigue analysis, fatigue vehicle, and the rail traffic load, all of them as per the Eurocode can be specified. So let's try to use the load model 1 for now. I want to just click OK to define it. Now what I need to do is make the link between my lane and vehicle. For the moving roads, so specify my desired lanes. That's all. When you are working with the moving road analysis, you know the results we are getting, like moment or shear force, they are not the concurrent force. They do not exist at the same time. Like the vehicle position when shear force becoming maximum and moment becoming maximum, all vehicle positions are not same. In order to check, but when you design, instead of using the envelope value, you want to consider those concurrent forces. How can check those concurrent force? If you go to moving load control, you can see this concurrent force option. Then program will automatically calculate the concurrent forces. So this is another very useful function. Okay, so all the desired data has been defined, and now I want to perform analysis and check the results. We have the 3-stage and moving load analysis, but analysis can be completed within very short time. So let's quickly perform analysis and check the results for each of the construction stage. During the performing analysis, I want to answer for your question. There was one question for the wizard, like the Girder bridge wizard. Is there only still Girder bridge? At the moment, latest version, yes, only still Girder bridge wizard is available. But in the upcoming version, which will be released beginning of September, we are going to have the PC Girder bridge wizard as well. So very soon we will have both PC Girder bridge and steel Girder bridge wizard. And there is another question for the design function that I will show you later. So, at the moment, the general shape of the PC composite section can be designed. I will show you in the demonstration very soon. And database section will be also covered in the end of this year. So let's try to check the results for now. How to check the results? It is also very easy and quick. For each of the construction stage, we can check their forces or the reactions. For each stages, we can check their reactions, or for the beam diagram, we can check their forces in the first stage and the second stage. So as the stage going on, the changes of the force can be checked easily, and also it can be verified for different type of the force, like due to the dead load, tendon primary, secondary force, and creep secondary, like that. So different components can be also viewed in the graphical format or the table format. So our users prefer to use MIDAS server because one of the big reason is this detailed results. You can check all the forces with the different components in the table format, and they are very well organized, which can also be exported to MS Excel or even the dynamic report, which is the Word format report. So those results will help you to verify your analysis results. For the moving load analysis, we can check the most critical vehicle position. For example, when the specify the desired element, and when the moment becoming maximum, where is my vehicle? So specify desired element and vehicle position can be viewed. As you can see, most critical lane have the different loading value for the lane number 2. So depending on the lane number, different value of the loading will be applied. And also if we want to check the shear force, similarly we can check their vehicle position with the value of the force. And as I mentioned for the concurrent force, for desired elements, we can check their maximum effect, which is the envelope value. So the vehicle position for this will be all different. But we need the concurrent force for the design. How can check? In the right clicking, we can see the view by max value item. So for example, if I want to see the concurrent force for these 3 components, then when axial becoming maximum, what is my concurrent force set? When the shear force becoming maximum, what is the moment? Same for the moment. So this concurrent force set can be automatically calculated, and it will be used in the automatic design of MIDAS 7. Now we want to move to the design. So similar bridge, now we want to perform the automatic design as per the Eurocode. For performing design, input data is also very simple. First of all, we need to have the load combination for the concrete design. After generating the load combination, moving to the PSC tab, specify your desired code, which is the Eurocode, and specify the factors. For example, if you are using the Singapore National Annex, you can specify your own National Annex value from here. So all the values are open, so you can use any of the National Annex for the Eurocode. After defining such data and specify the material, like the reinforcement has not been defined yet, so such reinforcement can be specified from here. And the desired position for performing the design can be entered. For the load combination, like the serviceability checking, what is the combination for the free permanent, quasi-permanent, frequent, and the characteristic load combination in the service load combination? It will be automatically classified when we are using the auto generation function of combination. But if you manually generate them, you can manually classify them from this dialog box. Also, for checking the crack, we can specify the exposure class. After that, after performing design, we can check the results in this table format. So if there is any element which is not satisfying, and they will be shown like this red color. So the member force obtained considering the construction sequence and the moment resistance considering the tendon primary force, it will be compared and we can obtain the ratio also. Similar for the shear resistance verification, or even we can verify the tendon stress. And also at the service stage, my stress can be verified in the different position, like the top and bottom of the stress, and it will be compared with my allowable stress. After checking such table, the arranged table results, you want to verify one by one, especially for some critical position of the element. For the purpose, we provide this Excel report. So once you click this menu, then you will be able to see this Excel format report. Very detailed report will be provided for you, like the section property and their material information and tendon information. After that, starting from the positive moment resistance calculation. What is my critical member force and how the resistance will be calculated, finding the neutral axis, and then calculating the resistance. For each of the parts, as you can see, all the equation and the factors being used can be checked from here. And the related code clause can be viewed as well. So such detailed report will help you to verify your bridge more easily and quickly. Civil is not like the black box, so you can see all the calculation, how they has been calculated, why this value has been comes out using this Excel format report. For the type of the section, at the moment, this main girder, I have generated main girder using the general section, which means using the SPC. At the moment, such section like the composite general shape section is supported for the design. But at the end of the year, another version is coming, and in that version, such composite IT, composite PSC, such section will be also supported for the automatic design. So at the moment, in the latest version, only composite general is supported, but the other three will be supported at the end of the year. This is under development. I would like to come back to our presentation, and we would like to continue to see some more features for the pre-stressed box girder. So we have checked the major features and Eurocode design features in the PC composite girder bridge.